Alright, check this example out here. I'm going to do 2 examples for y'all because it's Monday, trying to refresh our memories about this stuff. Are y'all paying attention there? Hunter, it looks like you're asleep. I know you're not asleep, but will y'all look up here, please? Alright, and it asks how long will it take. That's asking for time, so we'll say t equals blank. For an apple falling from rest, that's my next thing. Oh, I'm not underlining stuff, there we go. From rest means vi equals 0, because it started from 0, from rest. From a 29.4 meters tall tree, so that's a distance. We'll fix that up in a minute though. I'll show you something about that. And I can't remember if I did this for y'all already, but refreshing our memory here, no problem. Alright, we got our distance to hit the ground if it accelerates at negative 9.8 meters per second squared. That negative, again, just means that it's in the down direction. So when it says it's accelerating negative 9.8 meters per second squared, it's falling down, and that means it's speeding up by 9.8 meters per second each second in the down direction, and that's what that in the down direction is what that negative sign is saying. So all right, our variables, let's see, it mentioned time, that counts as it mentioning it. It asked for it, didn't give us a number, but it mentioned time, and initial velocity, distance, and acceleration. So just like before, because it didn't mention final velocity on there, just like before, we've got to find the formula that doesn't mention final velocity. And I can mute this so that we can see it a little better. And like I pointed out earlier, are y'all awake? Like I pointed out earlier, that's the top one, doesn't mention final velocity. That's the one we'll use here. Come on back, camera. There we go. Alright, so always write your formula out with just the variables. If you try to plug it straight in, you're going to mess it up. Okay, now, one thing here that I've got to fix up before I start doing this is, I said we're going to fix this distance up. Because this acceleration is negative, that tells us the thing is falling in the down direction. That tree, you know, it's a fact. That tree is 29.4 meters tall. But we're describing the motion of this apple. So this apple is up there, and then it's going to fall down 29.4 meters. So we've got to make this 29.4 negative. And now we're good to go to plug everything in. It would have been weird if we would have got messed up trying to take a square root with a negative number or something. But we fix it up, so here we go. So the thing's going to fall down 29.4 meters from rest. Looking for time. 1/2 is 1/2. A is the negative 9.8 it gave us. And T is, we don't know. All right. So let's see what we can simplify here. I guess we can do 0 times time, and we can do 1/2 times negative 9.8. So I'm going to rewrite it with that stuff simplified. I think my marker's dying a little bit. 0 times time is 0. It's really, this formula I think is one of the easier ones because whenever the thing starts from rest, this whole front part goes away. So it's not this whole long VIT plus 1/2 AT squared. Often it's just 1/2 AT squared. This makes it a lot easier when there's a 0 there. So 0 plus 1/2 times negative 9.8 is negative 4.9. And we got t squared there. This 0 is not going to add anything to this negative 4.9 t squared, so I'm just going to get rid of it here. So just pretend it's not there because it's not doing anything. I want to get t squared by itself. I want it to say equals t squared, and then I want it to say equals t, and then that'll be my answer, and I'll be done. That's going to be in seconds because of this time. I'll go ahead and write S. It says t squared times negative 4.9 over here right now, and I need to make that cancel, so it just says t squared. So since it says t squared times negative 4.9, I'll do the opposite and divide both sides by that negative 4.9. And 29.4 divided by 4.9 ends up being exactly 6, which is kind of neat. And that's fine. So I'm trying to go from t squared to t. Y'all remember what to do there?
Square root.
That's right, good. Yeah, square root. A lot of people get mixed up there, so. To get from, once you have t squared, that's not your answer yet. You gotta go backwards from squared. Do the opposite of squared to make that squared cancel. And then square root of 6. Do I remember what this is? I think it's 2.4 seconds. Pretty sure it's 2.4 seconds. And there we go. I want to do one more, if I can find it. One of these. Hold on. I guess, yeah, that's not the one. This is the one. Here we go. All right, thanks for your patience while I found the right one there. All right, this one is neat because it tells us that this car is initially moving backwards, and that's going to be important here in a minute. If y'all feel confident with this already, then please go ahead and go start that Kinematics 3. I'm still going to do this one, and I'll ask for everyone's attention in the important part here. This is going to be nice and regular until the very end, and then we'll fix it up. So, all right, car initially moving backwards undergoes an average acceleration of 5. Just because it says average doesn't make it different. It's still an acceleration of 5 meters per second squared. I'll write down A equals 5 meters per second squared. Okay. 5 meters per second squared toward Emily. If the car comes to rest, oh, that's different. That doesn't say from rest. That says to rest. So this one means that the final velocity is 0. If it's from rest, that means it started from 0. If it comes to rest, that's, it does some stuff, and then it goes to rest. So that happens after everything. That's why that to rest means final velocity is 0. And it says negative 9 meters. So that's because it's moving backwards. So it just means backwards 9 meters. Displacement is negative 9 meters. From what velocity did it begin? All right, so now it's asking for initial velocity. That'll be fine. So our variables, we got acceleration, final velocity, displacement, and it asks for initial velocity. It did not mention time now. So we need the formula that does not mention time. And if I can move this so we can see it better. The one does not mention time. Let's see, there's time there. That one's got time. This one's got time, so it's this one, this green one here. VF squared equals VI squared plus 2AD. So, always write the formula. If you try to start plugging stuff in right away, you You're gonna plug it in the wrong place. Okay, final velocity is 0, so that makes that easy. 0 squared is gonna be 0. Vi squared, we don't know what Vi is, that's what it's asking for, so we just write Vi. 2 is 2. Acceleration is 5. And displacement is at -9. Alright, so I can just change this to 0. Can't do anything with that yet. 2 times 5 is 10. 10 times -9 is -90. This marker man. I can add 90 to both sides, you know? Because I want it just to say equals Vi. I'm going to switch it down here if nobody minds. I want it just to say Vi, and then, so first it's going to say Vi squared after I get rid of this 90, and then I got to get rid of the squared, and then I'll have the answer. So okay, it says plus -90, so to make this -90 cancel, I can add 90, and -90 plus 90 is going to be 0, and now that part's gone. Plus 90, 0 plus 90 is 90. Now here, we're going to do a square root again, Vi squared. Square root of Vi squared is Vi, and so we're good. We're going to get the answer right now. The square root of 90 ends up being 9.9, but this is where it's kind of cool. All right, if you're working on this, good, but let me have your attention here because this is a slightly new thing. Let's go to math class for a minute. If you're in math class, what's the square root of 25? It's not just 5 though. What's your math teacher say it is?
I don't know.
Is it positive 5?
Yeah.
What about negative 5?
The square root of -25.
Well, if you take a number times itself, it's always going to be positive. So -5 times -5 would still be 25. So your math teacher would say the square root of 25 is plus or minus 5. And that works with the math we just did. Square root of 90 is plus or minus 9.9. That's velocity, so it's going to be meters per second. I can write my unit in there. But this is cool for us because negative means it's going backwards or down or whatever the opposite direction is in the question. So it told us this car is initially moving backwards. So its initial velocity will be going backwards. And since the square root of 90 is plus or minus 9.9, we know it's actually minus. We know which one it is, which is kind of cool. So once you take the square root, it told you it's going backwards, so you know that this is negative 9.9 meters per second, which just means 9.9 meters per second in the backwards direction. So that's kind of neat. Anyway, please get started on this Kinematics 3 here. No problem.